Hello, this is Mr. Weideman, Lafayette High School pre-calculus class. Today I'm going to do just a really quick recap of 4.3, what we talked about today in exponential functions. I'm just going to go toggle through these slides. You can stop the video at any time then if you need to supplement some things that you may have missed in your notes. And then I'm going to talk about what we didn't get to in class. So we talked about the exponential function, and then we learned how to do the parent function of an exponential function. We learned the domain and range of an exponential function. Okay, here's a couple of examples of graphing exponential function with different bases. Okay, and there is the t-table and graph of base 3. Here's the t-table and graph of base 1/2. And then we talked about, there we go, translations of a exponential function. Here's a example we did, base 2 with some translation, a horizontal shift left and a vertical shift down. And then we talked about a special exponential function, base E, which is just a magic number. We're going to get more into the properties of that magic number in our next section. And then we got the base of exponential base E. And then I don't think we got to this example problem where we do a translation of a log base E. All right, so when we do this, we are going to need our calculator. And like any other translation, we need to start off with the parent function. And where did I get those numbers? I put e to the -2 in my calculator, e to the -1 in my calculator, so on and so forth. My translation is just a simple addition of 1 to my x values only. That's how I got these guys, is by adding 1 to these guys. And then, very important, domain and range. Notice the range, we have a horizontal asymptote there. That's important. Okay. Solving equations that have exponentials. There's many ways to do this, and it can get complicated. But for right now, we're just doing one method only. When we learn a little bit more about logarithms, we'll have a different method. And this is the key to solving equations that have exponents in them. On each side of the equation, I want the bases to match. Okay, so this is what I'm looking to achieve. Notice that I have base B, and remember, B can be any real number except 1 or 0. M and N can be any expression, 2x plus 3, 5x minus 4, or just simply x, or a number, any real expression. Okay, and this should make sense. Remember, there's a big old fat equal sign. So that means everything has to be equal. So as long as the bases are equal, we have that big old fat equal sign, guess what? That means the exponents also have to be equal. And that's our strategy. All right, let's do an example problem and see how we're going to put this strategy to work. All right, now here is an expression. I have an exponential function on one side, and I have 16 raised to the 1 power on the other side. Now, base 2 and base 16 are not the same. So how am I going to make my strategy work? Well, I'm going to look at the 16, and I'm going to rewrite the 16 to base 2. 2 to the 4th power is 16. Now that the bases are the same, the exponents must also be the same. So I'm going to concentrate with them, and I'm going to set up an expression that says that these have to be equal. The bases are both 2, then the exponents have to match. So the 3x minus 8 must match the 4, solve for x. And it's that simple. Let's do some more. What are we going to do here? Well, we need to find a common base. We need to be a little bit clever. The common base for this problem is 3. 3 cubed is equal to 27. 3 squared is equal to 9. Now we have to go back into our Algebra 1 days, and we have to remember what we call our power rule. Okay, so I have an exponent raised to an exponent. All right, what do I do with these guys? And the answer is you multiply. All right, or in this case, distribute the 2. Let's see what that looks like. All right, so I distribute the 3, or I multiply 3 times x plus 3. What do I do on the other side? I multiply 2 times x minus 1. Now the bases are the same. I've used my power rule on my exponent, and now it's simple. I set the 3x plus 9 equal to the 2x minus 2, and I solve for x. Let's try another. Okay, this is something that typically gives students a lot of heartache. Fraction. Okay, now how do I match the base here? Whenever you see a fraction, I want you to think exponent to the -1 power. Okay, now these guys have the same base. Okay, 5 to the -1 power is the same thing as 1/5. So now I can go 1 minus 2x is equal to the -1, and we got it. All right, our last type of problem that we have to do is it's another graphing translation. And we did this, but I'm doing one that is particularly icky. So if you can do and follow this, then a simple base exponential translation will be fairly easy. Okay, now what do we got to do? We have to start with a parent t-table. Now, if the base is simple, I really expect you to do this t-table by hand. All right, our base is not simple. So I got these numbers with my calculator, the 0.14, 0.37, the 1. All right. Now, remember, the order in which we do our translations is important. Look at your foldable to make sure we do these in proper order. Okay, so the first thing I'm doing is the horizontal stretch or shrink. So what am I doing? I am taking this 2 and dividing all my x values by 2. Okay, so this divided by 2 gives me that, so on and so forth. Okay, so that takes care of that translation. Let's do the next. The next one is I multiply by -3. This kind of kills 2 birds with 1 stone. I get a reflection and I get a vertical stretch. Okay, so what did I do? I took every y value and multiplied them by -3. Okay, one more translation to go. The vertical shift. I add 7 to all my y values. And there it is. And then I plot that. Now, 90% of the time, 95%, our simple little 5-point t-table gets us to where we want to go. This is that rare time when our wimpy little 5-point t-table kind of leaves us a little bit in the lurch. So let's go ahead and plot this, and I have got some concepts here I want to share with you. There it is. Now, how did I know that that asymptote is right up there at y equals 7? When I connect these 5 dots, it really doesn't look like much. But we know an exponential function has an horizontal asymptote, and this particular function has been translated upward. Well, there's something that we can always go to the bank. This vertical translation will always be the horizontal asymptote, and that will help us design our graph. All right, now how come it's pointed down instead of up? Well, remember, we had a x-axis reflection. Oops, wrong thing. Right here. Okay, that's going to give us an x-axis reflection. Okay, normally that asymptote, horizontal asymptote, is the x-axis, but it got translated up 7 units. All right, now if you can handle this graph, you can handle everything. And last but not least, there is our homework assignment in case you didn't get it. Do give these guys a try. They're really not that hard. It is really plug and chug sort of stuff, and use your calculator with your little base exponential button, and I think you'll be able to figure it out. Okay, thank you for your time.